Hey everyone, it's Justin, and in this video, we'll be learning the do's and don'ts of using units in formulas. Every formula involves units. After all, a formula simply describes the relationship between two or more measurements, and usually there are at least two different units involved. So we have to understand how important it is to pay attention to those units. For instance, here's the formula for volume of a pyramid. We just plug in the values of B and H, calculated, and we're done, right? Well, not quite. See, each of the variables here has different units, and they have to be compatible before we can do any calculations. Say we want the volume to be measured in cubic meters. B, or the base area, will be measured in square units, such as square meters. And the height of the pyramid will be measured using regular distance units, such as feet. The problem is, these units here are incompatible. If we multiply the units for B and H, they don't give us cubic meters. They give us, well, something we don't even have a name for. If we want the volume measured in cubic meters, we'd first need to convert the height from feet into meters. Now the units are compatible, and we could calculate the volume. Here's an example using that previous formula. A pyramid has a base area of 600 meters squared and a height of 25 feet. What is the volume in cubic meters? Like we said before, feet are not compatible with other measurements that use meters, so we need to convert. 1 meter is approximately the same as 3.28 feet. So if we set up the original measurement, then use dimensional analysis with the conversion rate, we get 25 meters divided by 3.28. which is 7.62 meters. Now that we've converted our height into a compatible unit, we can finish our calculations. 1/3 times 600 times 7.62 is 1,524. And if we check our units, meters squared times meters gives us meters cubed for our answer. So the volume would be 1,524 cubic meters. All right, let's look at this one. Scientists are studying the prevalence of a plant species in two ecosystems. One team at Site A measures that there are 550,000 of these plants per square kilometer. The team in Site B reports 60 per square meter. At which site are the plants more prevalent? 550,000 plants per square kilometer and 60 plants per square meter. In order to be able to compare them, we need them to be in the same units. It doesn't matter which one we convert, as long as we end up with the same units for both. But let's convert the square kilometer one into square meters. Even though we don't have a conversion rate for square kilometers to square meters, we can use the kilometers to meters conversion rate. Remember, 1 kilometer is the same as 1,000 meters. How will this work on square kilometers, you ask? Well, square kilometers means the same as kilometers times kilometers. If we use the conversion rate once, it cancels one of the kilometers units. And if we do it again, it cancels the second one. Notice that we now have on the bottom two meters units, which we will multiply to make meters squared. Now all that's left is the calculations. On top, 550,000 plants times 1 is 550,000 plants. And on bottom, 1 times 1,000 meters times 1,000 meters is 1,000,000 meters squared. Now we divide, and we get 0.55 plants per square meter. Even though it looked in the beginning like Site A had way more of the plants, it was only because of the difference in units. Site A barely has any compared to Site B. Let's do one more. A car travels 300 miles in 6 hours. How many feet is it going per minute? This time, multiple measurements are in the wrong unit. There are two ways we can correct this. We set up the speed as 300 miles over 6 hours, then do dimensional analysis, or convert both measurements and then plug them into the formula. We'll do it the second way and convert before we use the formula, but feel free to try the same problem using dimensional analysis. To convert miles to feet, we multiply the amount of miles by 5,280. So 300 miles is 1,584,000 feet. To convert hours to minutes, we multiply the number of hours by 60. So 6 hours is the same as 360 minutes. Now that we've converted both, we can plug them into the formula for speed. All that's left to do is divide, and we get 4,400 feet per minute. Again, the same problem could be done using dimensional analysis. So I encourage you to try it yourself and see if you get the same answer. The next lesson will focus on using dimensional analysis to solve problems that include their own special conversion rates.